Hello, this video is for Stat 210, handout number 7, and will include a discussion of pages 17 through 26. Okay, let's go ahead and get started then. So where we left off in class was talking about how to compute the relative risk ratio. So let's go ahead and bring the example in that we were working on in class. It was this one here where we were considering the exposure level against whether or not somebody had airway obstruction. We were getting the relative risk ratio here under that menu option. So let's go ahead and show you that again. We want to specify that we're talking about airway obstruction yes category. And then we have to identify what we want in the numerator. And again, that is the level that has the larger box that we're comparing. So that's going to be high here. We'll say OK, and we get that output dumped out. And you can see that the value that we get from that relative risk ratio is 2.5 here, where my cursor is at. And we also get a confidence interval. So that's what I want to pick up with first here, is just a brief discussion of the confidence interval and what that means. So here is the information about how the confidence interval is calculated. I don't really want to go through all of these calculations because the JUMP software will provide that for us. One thing I will say, though, that is unique about the confidence intervals that we're going to be looking at here is that it is based on a ratio, right? It's a relative risk ratio. And one thing that we often do when we're computing a confidence interval for the ratio is to take the natural log of that ratio when we're computing the confidence interval. So here's the formula for the lower endpoint and the upper endpoint. The A, B, C, and D values are just given by the numbers that are found in each of those cells. So that's how this is set up. This missing quantity here is going to be 1.96. That's going to be pretty standard throughout. So that is just based, sorry about that. That is based on just the normal distribution and the fact that the standard normal distribution, if I use the values negative and positive 1.96, I will end up with 95% of the area under that normal distribution. Now, one thing that I have to do once I get these quantities is to raise them to the e power, because we did the natural log here in the beginning, so I need to put them back on the right scale. So once I compute these quantities, JUMP is going to raise those endpoints to the power of e there, and then that is what we are given back by JUMP. So the lower endpoint for my 95% confidence interval for the relative risk ratio that we have here is 1.04, and the upper endpoint is 5.99. And my relative risk ratio that I computed there is 2.5. So here I have just that interval sketched out for us. You can see that the interval starts here at the 2.5. This would be the negative margin of error, and then this side obviously would be the positive margin of error. One thing that is unique about the confidence intervals that we're looking at here is that the negative margin of error does not match the positive margin of error. It does match on the natural log scale. So the amount that we're subtracting, right, this quantity here would be the margin of error, and the amount that we're adding is the same on the natural log scale. But when I raise that to the power of e, those aren't symmetric anymore. So one unique thing that happens when I compute margin of error quantities for ratios is that the negative margin of error and the positive margin of error are not going to be the same. So how do we interpret just the 2.5 again? If we talk about how we did that in class, we just say those that are in the high exposure group are 2.5 times more likely to end up with airway obstruction than those in the lower exposure group. Again, it has to do with what we're putting in the numerator compared against what we're putting in the denominator. If I have to interpret the confidence interval, that's going to be the same, okay? Again, we're 95% certain that those in the high exposure group, okay, have anywhere from 1.04, because that's the lower limit, up to 5.99. Okay, so that increase in that rate is going to be anywhere from 1.04 up to 5.99 times higher. Right, so that's how we interpret a relative risk ratio, is it's 2.5 times higher. Well, now we're giving you an interval, because I don't know exactly where that quantity is going to be if I were to get another set of data. But again, I know this interval here captures that true relative risk ratio 95% of the time. So the interpretation is here. We're 95% certain that those in the high exposure group will have a 1.04 up to 5.99 times higher rate of having airway obstruction compared to those in the low exposure group. Now, one thing to note is that 1, as we talked about in class, 1 would indicate no difference in that risk. So if these two boxes are exactly the same height, when I compute the ratio of those two, where are those two boxes again? Way up here. If those two boxes are exactly the same height, then that ratio is going to be 1. The fact that my confidence interval stays above 1 here, it's close on that lower end, but it does indeed stay above 1, I can say statistically that that high exposure group has a higher rate of airway obstruction. If this confidence interval were to reach down to 0.8, for example, then 1 would be captured by that interval, and I would not be able to be 95% certain that the rate is higher, because it captures 1, and again, 1 indicates that there's actually no difference in the risk. So one thing that you want to pay attention to when you're looking at these relative risk ratio confidence intervals is whether or not they capture 1. And if they do, there's statistically no difference in the risk. When we get to the p-value discussions, that'll mean that that p-value is, what, bigger than 0.05? If it actually captures 1, that's going to imply that there's no difference in the risk, which would be indicated by a large p-value. If the p-value is small, okay, which it would be in this case, the p-value in this case is going to be less than 0.05 because this confidence interval does not reach down to 1. And again, 1 indicates no difference in the risk. Talk a little bit about the risk difference here. So if we go back to, let's bring that window back. Oops, not that one, that one there. If I want to compute the risk difference, what I do there is select 2 sample tests for proportions. Now this isn't a great name, but it is what it is. So 2 sample tests for proportions will actually compute the difference in the risk for me. So this difference here is 15.5%. And that's just that difference right here. So the difference between the height of the white box on the right and the height of the white box on the left is 15.5% here. Now, one thing that's true about the risk differencing is that it does not matter if you're comparing the white boxes to each other or if you're comparing the gray boxes to each other. That difference is still 15%. You can specify what category you're looking at. So this is going to be looking at the response where the airway obstruction was yes. And you'll notice that, so now I'm just comparing the white box to the white box, but it is putting this box first. So it's actually the math that's happening there is 10.3% minus the 25.9%. That's where we're getting the negative 15.5%. Again, if we leave it as no, then that difference is just the positive version of that. Likewise, we're going to have a 95% confidence interval. And this is computing using a formula that I have in the notes. But again, you don't have to be worried about that. We're just going to use these values that we get from JUMP in order to look at those quantities. Not going to make you do the calculations there for the confidence interval stuff. So here's that 15% difference that we were just talking about. Again, how I would communicate about that is that those in the high exposure group have an increase of 15% or 15.5% in the rate of airway obstruction compared to those in the low exposure group. So the interpretation there is fairly straightforward. Again, you just want to look at or explain what two boxes are you comparing there. Again, here's the formulas for the confidence interval. I am showing you in the notes that you can get either version, the positive or the negative. And one thing that happens about the endpoints is they just flip on each other. So if you want the positive version here, that's a 15.5% difference. The low end would be 1.2%, and the high end would be about 28.8%, it looks like. Again, the missing quantity in here would be the 1.96. That's always the missing quantity in these intervals. Here's what the endpoints look like if I sketch those out. Again, the lower endpoint there is 1.2%, and the upper endpoint is the 28.8%. I'll say it again, if you do the negative version, then it's obviously just going to be the opposite endpoints here. So the interpretation here, so what did I say the interpretation was for the 15.5? I said those in the high exposure group have a 15.5% increase in the rate of airway obstruction compared to those in the low exposure group. Well, if I'm doing a 95% confidence interval for the difference in the risk, then I would just say that risk difference is 95% certain to stay between 1.2% and 28.8%. So my interpretation here would be just that we are 95% certain that those in the high exposure group have a 1.2 up to a 28.8% increase in the rate of airway obstruction compared to those in the low exposure group. Now, when we're doing risk differencing, 0 is going to be my point of interest here. So if I'm differencing these two, 0 means there's no difference in risk. So where is my two boxes again? If this distance right here is 0, okay, then that difference in risk, well, the two boxes will be the same height. Let me say it this way. If this is 10.3% and this one's 10.3%, if I were to difference those, that would be 0. But if this was 10.3% and this one was 10.3%, the ratio of those two would be 1. So again, our baseline value for these is different. It's 1 for ratios and it's 0 for differencing. So this interval is completely positive, right? This interval is completely positive. It does not go down into the negative region or doesn't reach 0. So I can say for certain, I'm 95% certain, that the risk for those in the high exposure group is going to be higher because this interval never reaches below 0. If the interval was completely negative, so if 0 was up here on this end and the interval was completely negative, like this version that I have here, we would still say a difference exists because the interval does not capture 0. And what the low exposure group, or excuse me, the higher exposure group would have a higher rate here. That's how you get a negative value, is if this thing is higher than this one over here. So you'd be saying the same exact things, it's just how was the math done to get this differencing. Okay, let's talk about odds ratios then. So odds ratios are a comparison of odds, okay? And one thing that's unique about odds is it is not based on the row percentages, but instead they are based on just the counts themselves. Okay, so if I wanted to know what are the odds of a low birth, so I got 41 low birth and I got 115 normal births. If somebody were to ask what are the odds of low birth for those with no previous history, how we would write that would be 41:115. So let's go down to the next page here and look at that. So here I'm breaking the two columns into two parts here. Let us just consider the odds of low birth for those with no previous history. Now I'm asking for low birth, okay? So I definitely want to put the 41 first. So maybe let's make this a little bit more clear here. If the odds of low birth for no previous history, we're going to write that as 41:115. Because we're saying odds of low birth, that's going to go first there. So it's going to be 41:115. Over here, for those with some previous history, so let's look at the other set over here, the odds of low birth for those with previous history, okay, the math for that is going to be 18:12. That's how we would write that. Ran out a little bit of space there. 18:12. Again, they're asking for odds of low birth, so 18 goes first, and then I put the normal birth second here. Now, if we were to want to compare these odds against these odds, what we would do is compute an odds ratio. So that's what we have here in the notes. So how are the odds ratios computed? Again, we're going odds ratio for low birth, so that means the 41 has to go first. 41:115, all divided by 18:12. Now, we cannot do a mathematical operation with the colon in there. So what we do is we just take the 41 divided by the 115, and then we take the 18 divided by the 12. Okay, so that's a sleight of hand that we do when we're computing an odds ratio. Now, when we do that math, we end up getting 0.2377. And just like a relative risk ratio, we want odds ratios to be bigger than 1. So again, I've done this math backwards here. So I want to flip these around. So what I want to do instead is put the odds of low birth weight for those with previous history first, or I want to put them in the numerator, excuse me. So let's recalculate that odds of low birth, but now I'm putting the previous history in the numerator. And I get a ratio of 4.21 now. So how do I interpret these odds ratios? It's going to be very similar to what we had when we looked at the relative risk ratios. You're going to start by, so the interpretation here is going to be something like the odds of low birth for those with previous history, right? Because that's what I put in the numerator, is, or are, 4.21 times larger or greater than, and what's in the denominator here? The odds of low birth weight with no previous history. So literally can just copy that, but this is for the no, with no previous history, I guess it would be. So it's the odds of low birth weight with previous history, that's in the numerator here. That's the 18:12. Are 4.21 times higher than or larger than. And then what do I have in the denominator? Odds of low birth weight with no previous history. So that would be the interpretation there. When we're computing or interpreting odds ratios, we need to make sure and communicate the fact that we are indeed comparing odds here. This is not the same thing as saying the chance of a low birth weight baby or the probability of a low birth weight baby. If you're doing probability or chance or the likelihood, then you're doing that out of the total, right? You're doing those row percentages. An odds ratio is not based on row percentages. We are not taking 18 divided by 30 here. Instead, we're taking 18 divided by 12. That's not the same as a row percent. Okay, so there's definitely a difference in the interpretation of relative risk ratios compared to odds ratios. An odds ratio of 1 is, again, our reference value. If I have an odds ratio of 1, it means that the odds in the numerator are the same as the odds in the denominator. The only way that I'm going to get 1 here in this calculation is if the odds in the numerator match the odds in the denominator. And that's going to be the situation of no difference in odds. If they're greater than 1, okay, oh, excuse me, we often compute these things so that they're greater than 1. Again, that's just for ease of interpretation. Now, when I'm doing these in JUMP, so let's bring, yes, this example here is the one we're looking at, where I have previous history. This is the 41:115:18:12. If I ask for the odds ratios here, so let me go ahead and do that, it doesn't ask me which ones I want computed or how I want it to be computed. And in fact, the default here in JUMP, I guess, actually did it backwards. I was working with the value, what was I working with? 4.2 or 4.5 or something, 4.2. The default actually computed the 0.2377. So what you have to do to fix that, it's not like the relative risk ratio, where you get to pick what's in the numerator and denominator. What you have to do to actually fix that is to just swap the order for the response. So if I go column properties, value ordering here, and I put normal on top, so flip the order for the response, and now if I go ask for an odds ratio, it's going to compute it the right way for me. It should have computed it the right way there. Let me just double check that. Maybe I need to flip what normal. Let me just be careful here. I might have to say redo analyses. Might have to redo it. So let's go back to my data table here. Got too many windows open for you. And reconstruct that. Low birth is my response. Previous history here. Okay, that's looking better. And then I say odds ratio. And if I bring that up into your view, you can see that indeed it's 4.2. 4.21. So I just had to recreate that graph to make those odds flip. I could have also said redo, I think it's redo analysis, and that would have updated things as well. So again, it's not quite as convenient as selecting what you want in the numerator and denominator when you're doing the odds ratio. You got to go back and flip the order. And my lower and upper endpoints are about 1.9 and 9.5 here. Again, that negative margin of error and positive margin of error are slightly different because of how that confidence interval is computed. But again, these are for odds. So when you're talking about this confidence interval, you got to be talking about the odds of low birth weight. And we put what group in the numerator? I think we put those with previous history in the numerator. So you want to talk about those first in those discussions. Okay, that's all I have here. We're going to start up with page 27 when we get back in class on Friday. So thank you very much and have a good day.